Um, I am now checking to make sure that I am actually on. So if you see like, if I remembered to index it, you should have something like skip or start in the index so you can just get there if that you're watching this later as a VOD. So let's check YouTube and Twitch. I decided like, I could set more of this up beforehand, but then everything just gets like really hard because like I have to do so much stuff that I'll never start streaming. So I'm just like doing it after I click the start button. It's a little bit easier. All right, so where are we with YouTube? Connect to stream. It looks like we're live on YouTube, so that's good. All right, now let's check Twitch. I was sick if you saw my last streams, and it was just like a mess. So I'm glad that I'm not sick anymore. I guess I can say that now. I'm not sick anymore. It was like, it lasted a long time because first I had like food poisoning, and then I got a cold. So it took a while to get through all of those. Hello, hello. Who's there? I think today I'm gonna try to continue learning TypeScript. The good news is I think I got the contract to do some work, and I'll just have to make sure I know TypeScript. So I'm gonna keep going through that documentation. I also am trying to stream on PeerTube, so let's see if that's working. Current lives. Well, it works. Do I shake like this a lot? I feel like when I see myself on the stream, I'm like moving around all the time. All right, let's see if chat works on my crowd. Here, hello everyone. All right, so my crowd messages don't show up on my little console here. So unfortunately I won't see that. I wonder if there's a way for me to pull this out. Doesn't look like it. So I'll just kind of move this over here. And then we'll get started. I'm like also really tempted to do some Atari 6502 programming because it's been so long. And it's like I really enjoy it, but there's also this need to program to learn TypeScript soon. So I guess I should do that. Maybe we'll be able to do at least a little bit of 6502 later. We'll see how that goes. All right, I think we're set. So I just have to bring up a browser now. And we will be able to go into this mode. Let's get the browser on here. What the heck? Oh, here's Chrome. It's like I've never done this before. TypeScript. So I'm trying this new search engine, Mojik, because I'm like trying not to use Google as much since like Google has $1 billion and doing everything to make sure I stay on Google. And this one, like, there's a lot of other alternatives, but they mostly use either Google or Bing search index. So Mojik does not. Brave also doesn't, but it's with Brendan Ike, who created JavaScript, but he's sort of like, I remember he was, I think it was anti-LGBTQ plus, donated money, and also what was the last thing he just did? He said sorry for that, but then he did something else. So it's like, whatever. I'm not really a big fan of that. And also they have like AI or crypto or something on their site. So not a big fan of that. So this one seems okay. Wow, are you AI? Why do you say that? Are you AI? What does that mean? Um, I'm a pineapple. So yeah, it seems to work pretty well. Here we go. TypeScript is JavaScript with syntax for types. I think we're doing this and we're using the handbook. Trying to remember where we got through. I think we got through basics. Yeah, I'm a real person. But what would make you think I'm not a real person? I'm definitely a real person. Well, as far as I know I'm a real person, shit, how do I know? Are you real? That's the kind of question AI would ask, just to make it seem like they're not AI. Always start with the offensive. On the offensive. Okay, so what are we doing here? Did we do all this? I think we did basics. Did we get to erase types? I think so. Down leveling. I feel like I forgot a lot already. But that's why we made this gist thing. It's a crazy world. It's totally crazy world. We made a gist where I wrote some things about TypeScript. Okay, so reminders to myself was JavaScript in general, because I'm not a big JavaScript programmer, needs return. All their functions do not return the last value. Using an optional proper doesn't always give a warning. Using in string interpolation emits no error. Right, so when you in TypeScript you can put a question mark to say that a property is optional. So if you do that and all you do is, and you don't pass that property, but you use that property in string interpolation, it doesn't complain. The compiler doesn't care. Um, so that's a tricky thing, I guess. Not a big deal if that's all you're doing, I guess. Arrays are objects, so when using them as types, you can't narrow using type of. Yeah, I think all I was doing here was that I was using a switch statement or case. Yeah, it's called a switch statement. And but a switch statement, if you call like type of on an array, you'll just get object, which isn't so great. So that's something to note. JavaScript stuff. Var statement. Yeah, the difference between var, let, const, and var and let. Let is lexically scoped, and var looks like it's either function or globally scoped. I wonder how it knows which one it's going to be. Compiler options, and then we have our types here that we learned about. Symbols. Oh yeah, symbols are like atoms. Symbol is an atom. Making a type. Right, so I was wondering how to make a literal symbol. So what am I doing here? Are these the same? Oh, how do you make a type? So this is making a type from a literal symbol. You want to say it has to be the symbol. So you do a type that is type of and then the symbol. That's what you do. So you have to have a const symbol and then you do type of that const symbol. Maybe some of these things are good to practice. TypeScript playground. I also tried installing, like, I'm on this whole thing of where I want to stop using like these big company stuff so much. So I set up another search engine called Yasi. I think that's localhost here. But it seems kind of crappy. Like, you can see, like, let me show you, like, it connects to all these peers and it does a lot of indexing. It's a federated decentralized search engine. Where was like, you can kind of see the peer-to-peer network, what you're connected to. This is the system status. But when I actually try to search for stuff, it's not that great. So if I go ahead and search something like, let's see, TypeScript playground, it's kind of slow. And it has some stuff, but look, it's like, it doesn't give us the one that I actually wanted, which was TypeScript playground that Google gave. So one thing you can do is like you can help build the search engine by like telling it to crawl stuff. So I'm going to play with this a little bit more and see like if it can be improved. You go to the start crawling, and then you just say start new crawl. And now it has like 3,500 things to crawl, I guess. So you can see it's trying to get typescriptlang.org. So after it's done, at least it'll be in my search so that like next time I try to find it, it'll be there. So you can see this number is changing because it's actually indexing it. We'll come back to that and see if it's any better later. Anyway, yeah, let's try to write this code again because I don't write JavaScript very often. So what are we at? We're trying to what is it, // for comments? Or is it hash? Let's say //. Create a literal, a type for a literal symbol. So we'll create a symbol that's like let s1 is equal to symbol my symbol. But we need this to be a const because it's a literal symbol. And then we make a type called s1 type equals type of s1. And now what this will let us do is we can have a function that takes in can take in a number. Let's say it takes in a number like time, duration, and it can be either a number or a symbol. Let's say like this, right? And let's say all it does is it does console.log on the duration. All right. Symbol to string will fail. Oh, we have to wrap it in string. I don't know how that works. That probably calls a string function. Let's just try this out. So when I run this now, I got what? Function statements require a function name. Ah, right. My function. All right, we have no errors now, and now let's try using it. If we pass in a duration of 33, then it says duration is 33, and we have no errors. And hey there, Blocks Hub Roblox. Someone was asking if I'm AI. I have no idea why. I do feel a little bit more AI today than usual, though. Maybe that's why. So we see here that it's fine with passing in 33, but if I pass in a symbol, let's make another symbol. My other symbol, my favorite symbol. And then here we try to pass S2, it'll say you can't do that. Right. But if we pass in S1, then it's fine. Duration is symbol, my symbol. So there we go, that works. Now, I know this is a little contrived, right? But you can imagine something like a symbol for run, another symbol like run, stop, and let's say pause. Oh, there's something called stop already? This is just Elise pause, Elise run, Elise stop, whatever. And now we make a run, we make a type. I think in JavaScript it's supposed to be capitals for types, right? Maybe we have to do like operation type is the way they do it. Right, so duration, and we say operation is equal to operation string op. All right. So then we say something like, I want 33, I want to start. So this currently works, but if I pass in, so if I run this, it'll say operation equals run. But if I pass in e stop, it won't work, right? But I want it to work. So how do we make it so it can be any of those? I'm guessing that we can just do this and also stop. And now this works. You see, it takes in stop. But if we want to say pause, it runs pause, but it's an error because it's not a valid operation. So, yeah, obviously we would then add pause here, and now it's valid, right? So you can imagine a function that basically takes in like, okay, what are you trying to do, right? Like, this would be like maybe a different thing. It wouldn't be a duration, but you would either say, I want to run, stop, or pause this. Let's say it's a PID, like a process ID. And we would say like modify process. So we're passing process ID 33 and we want to pause it. And this can like pause it, right? But we don't want to, like, if someone else made a symbol that was just like, oh, you mistyped it or something like that. I wonder what happens if I do foo here. I pass in foo. Yeah, this doesn't work. It's not the same function. But yeah, it makes sure that I don't pass in any other enumerable, sorry, not enumerable, symbol other than the ones allowed here, which is kind of cool. Um, because if I just change this, the other thing you would do is maybe you just do symbol, right? And symbol's fine if you do epause, but I can make a new symbol and it won't be cool. Bad symbol. And TypeScript here wouldn't know that this is bad. It doesn't know. So it's better to have the operation type here, and then it's like, oh, that's bad. You can't do that. Maybe we should save this as an example. Invalid symbol. You can get rid of this guy. And then we make a type here. Modify process, operation. And we say does not work. But the others do work. All right. Oops. We can save that in here. Symbols. Where did I put it? Here it is. I think this will be a little clearer as an example. Create a type for a list of literal symbols. Oh, the highlighting's not good. That's too bad. How you doing? How's everyone doing? Let's see, does anyone watch on PeerTube? Someone is watching on PeerTube, or is it just me? It might just be me. What did I call the name here? Oh, I did call it TypeScript, so the stream name is good. It's so cold still, like it's near 0 degrees Celsius here. Oh, it's 5 right now. It's gonna go down to -1. I have to leave for choir today. Every time I stream, my nose gets all clogged up. Why is that? I mean, just for now. Well, maybe I'm still a little bit sick. Alright, so where were we? We were looking here, strict null check. So I guess we're up to everyday types. Maybe we got through some of this. Arrays, any. Yeah, we got through some of this. Oh, and then the lambda function was really cool. Let's write a lambda function. Write a lambda function. This is just for me to practice, so I try to remember. So let's make an array of like words, I guess. And it's like I am screaming. And now we're going to map it, and I think that's like, what is it? Isn't it just like words.map? Right? So we give it a callback function that takes in a string. What? Index? What the fuck? Anyway, let's write one. It says up to 3 arguments. So let's just pass 1. That's the string. So we pass in the string. And then we're going to call string.to lowercase. And then we can say like softer words. And then we'll log it. Please whisper. How come I have to give backticks for these? Is there a reason why it can't just be normal quotes? Okay. Please whisper, I am screaming. So this is our lambda function. I think if we had multiple parameters, we might need parentheses here. Let's try this. We will interpolate this and add I in here. Let's see if this works. No, it looks like it's not happy with the syntax, so maybe we do this. All right. Yeah, I 0 am 1 screaming 2. So you need parentheses when you have multiple what's the third one? Index array string. What's the third one? This arg. Yeah, I don't know what the third one is. Maybe it's the full array. That's just kind of silly, right? Okay, so that's where we were with lambda functions. We did return type annotations. Here's the lambda function. Object types, we did object types, right? Object properties. Union types, right? This is the OR. This is like narrowing. Type aliases. I thought we did this a while ago with the type aliases, though. And then we had an interface, which was a lot like a type, except what was the difference? You can extend an interface, and with interfaces you can also like replace stuff. You could extend both of them, but you can actually like modify an existing interface. But it's hard to do with a type. I think that's what it was. So here you see we're extending animal, we're making new interface bear, and you can do that with, well, how do I, where's the thing to like scroll? Oh, it's on the bottom. So with types, you can extend it also. You make a new bear type and then you say animal. But the thing that's harder to do is to basically modify an existing interface. You can just say interface again and then just add a new field, which is crazy to me. But with types, I guess you can't. You can't, like, there's no way to do that. But who cares? You shouldn't be doing that. That's how it feels to me. I'm getting cold. I might need a jacket. Maybe that's why I'm getting like those issues. I'll be right back. Oh god. What was this one? All right, as. The as thing is basically, yeah, it's kind of an assertion, but it's really like conversion also. Not conversion, it's just like, what's that called? It's like casting. And that seems kind of dangerous. But it will always like, I think it does checks, right? Yeah, more specific type. So at least there's some testing here, but still. So you can't like say cast this to a number. literal types. Yeah, we did that already too. That's when I started figuring out, like, how do I do a symbol literal? It's a lot like this. The way I was using symbols, they're just using text here. But text is tricky, right? You kind of like, well, whatever. Text is tricky. You have to kind of like, I'm assuming they have to do a string comparison. Whereas symbols, I'm guessing it's just like a pointer comparison. What was this? Literal inference. When you initialize a variable with an object, TypeScript assumes that the property of the object might change. Ah, right, right. I ran into this. Here we're saying it has to be get. And now we're calling it with request.method, which is get, but it doesn't know it's get, even though it looks like it's obvious it's get here. Because it's like, well, it's a variable, so maybe it'll change. Who knows? So there's a few ways around it. Yeah. I don't think I would generally avoid like this whole thing by having a type for this object already. And then you can just say rec is this type. You do rec colon object type here, and it would know this method is the literal get. That's what I would do. Hey there, I can't listen, but I tuned in to boost the stats. Good luck and keep going on. Thank you so much. Yeah, I hope you have a great day. Non-null assertion. Right, I think I remember that. I determined this was just dangerous to use. We're going to learn about enums later. And then we have big int symbol, and that was it. Oh, so we finished everyday types. Cool. So we're up to what? Narrowing? Yeah, we're up to narrowing. All right, so now we're starting. I know it felt like a lot to get started, but this is just how I learn anyway, so not changing it for the stream. On this page, type of, type guards. Oh, they used the word guards. That's cool. Truthiness, narrowing, blah, blah, blah. Let's see. Okay, let's just get started. Imagine we have a function called pad left. And then here we're taking in a padding, which is a number or a string, and the input string. It returns a string. And we're not implementing something yet. If padding is a number, it will treat that as the number of spaces we want to prepend to input. If padding is a string, we should prepend padding to input. Let's try to implement it. Yeah, it's always like I like to not look at the implementation, and maybe they told us enough for us to do this. So let's try to remember what they said. So, forget it. I'll just write the function. Function pad left. It takes in I guess, padding. That can be either a number or a string. Is it lowercase string? I think so. And it also takes the string to work on, so let's just call that S. And this thing returns a string. Is it called exception? I guess not. Let's just take a peek again. Well, we'll just return not implemented. How's that? What? Oh, right. Is it because I need to return? Yes? Okay, now we're happy. So how do we start? If it's a number, then we're going to add that many spaces, right? I wish I knew the syntax for this. There we go. If it's a number, what is it? Colon? Oh, is that not how it goes? Case. Ah, case. We're okay. We know how to program. The types are not relevant at runtime, so they aren't really a string comparison happening at runtime. How come I don't see all the chat? Oh, I'm sorry. I didn't see your chat from a while ago. I'm so sorry. Ah, you're right. Good point. So does JavaScript have symbols though? Is that a JavaScript thing? So yeah, it looks like they have a symbol. Right, but either way, even if you get rid of the type stuff, if you're passing around strings and you want to check if it's the same string, isn't it going to do a string comparison? Whereas a symbol it won't, even if you get rid of the type checking. Because we're talking about like passing in alignment as a string. And then somewhere in that function, you're going to be like, if alignment is equal to left, if alignment is equal to center or whatever, that's going to do a string comparison, right? I think so. So therefore, you have a runtime hit when you're passing around strings rather than if you had a symbol there, you would just say if it's equal to the left symbol, right? And then that would be like, I don't think there should be any comparison there. What a mess I am here. Alright, so if we're a number, then we're going to return a string. How do I do basically like... Does string have repeat? Yes. And I'm guessing I can like just add it to string. I guess this could be default. I think that's right. So here we're checking if it's a number. And then we're going to repeat the padding padding times. And otherwise it's a string. Here it knows it's a string. Look at that. If I do this, oh, it still thinks it's a string. Here it's a number, thinks this is a string. What if it's a Boolean now, right? Doesn't tell us anything. Isn't that dangerous? Makes me think I should probably, just for better code, I should probably do string. And then have a default where I throw an exception. However the syntax is for exception. Let's take a peek. It's throw new error. Unknown type for padding. Alright, so now let's try running this. Pad left, and we're going to give it a number. 10, comma. Hello. Is there like a way to go to the end of line in this editor? Run. Oh no! It repeated hello 10 times. I want padding. I want space repeated padding times. There we go. There's 10 spaces here and it says hello. And then if I give it a string, pad, it puts that over there. It just couldn't fit it, so there we go. You see pad gets prepended to it. So there's our implementation of it. Let's see what they say. We have the same function signature. They made an error. Type of padding is equal to number. Otherwise return this. Yeah, they didn't do an else. If this mostly looks like uninteresting JavaScript code, that's sort of the point. Apart from annotations we put in, this TypeScript code looks like JavaScript. Maybe we should make chat a little bit darker because it's hard to read with these colors. It's like dark versus dark on dark. Let's see if I can do that. Do I know how to do this? No, not now. I don't remember. Oh, let's see how the Yassi stuff was going. Oh, it's still not enough memory space. Come on. This thing is just has lots of little issues. But if I do a search on what was I trying to search? TypeScript. Well, it gave me a result now. So that's good, right? Why the hell is it getting it from remote? It should come from my local. I swear to God. Yeah, see, you're just not gonna work, are you? Yeah, I don't think it's gonna be a very good solution. Okay. Why did I just do that? I forgot. There's a lot. While it might not look like much. Wait, did I finish the sentence? Did I just like decide to just stop and go to search? Jesus, how do you guys? The idea is that TypeScript's type system aims to make it as easy as possible to write typical JavaScript code without bending over backwards to get type safety. While it may not look like much, there's actually a lot going under the covers here. Much like how TypeScript analyzes runtime values using static types, it overlays type analysis on JavaScript's runtime control flow constructs like if-else. Let's see. Type of padding. It looks the same. The JavaScript code looks the same. It just removes all the type stuff. Makes me wonder, like, with that other like function we wrote with the symbols. Let's see what it does. Right, I guess it does nothing. Maybe because maybe because of this, we could just get rid of this. But yeah, looks like there's nothing really overhead here. That's interesting. Okay, where was I? It overlays type analysis on JavaScript's runtime flow constructs like if-else, conditional ternaries, loops, truthiness checks, etc., which can all affect those types. Right, right. That's what we're doing with the switch. Within our if check, TypeScript sees type of padding equals number and understands that as a special form of code called a type guard. TypeScript follows possible paths of execution that our programs can take to analyze the most specific possible type of a value at a given position. It looks at these special checks called type guards and assignments, and the process of refining types to more specific types than declared is called narrowing. In many editors, we can observe these types as they change, and we'll even do so in examples. Yeah, I was doing this, except remember, like, when I added Boolean, it didn't seem to know that it just thought it was a string. There are a couple of different constructs TypeScript understands for narrowing. Type of type guards, string number bigot, Boolean, undefined object function. Like we saw with pad left, this operator comes up pretty often in a number of JavaScript libraries, and TypeScript can understand it to narrow types in different branches. In TypeScript, checking against a value by type of is a type guard. Because TypeScript encodes how type of operates on different values, it knows about some of its quirks in JavaScript. For example, notice in the list above, type of doesn't return the string null. Check out this example. There's no null. So we say it might be null, and we say if it's equal to an object and we're using it, here we're using it saying, hey, this could be null. I guess because null is an object. If the in the printall function, we try to check if st of strings is an object to see if it's an array type. Now might be a good time to reinforce that arrays are object types in JavaScript. But it turns out in JavaScript, type of null is actually object. This is one of those unfortunate accidents of history. Well, that really sucks. Users with enough experience might not be surprised, but not everyone has run into this in JavaScript. Luckily, TypeScript lets us know that strings was only narrowed down to string bracket bracket or null instead of just string bracket bracket. Well, that's really helpful, even though, like, you'll see that error, you'll be like, what the hell? It's not null, but then, like, it is. It could be possibly null, so that's good. Truthiness narrowing. Truthiness might not be a word you'll find in the dictionary. I think it is. Ah, look at this. Dictionary.com. The quality of seeming to be true according to one's intuition, opinion, or perception without regard to logic, factual evidence, or the like. The growing trend in truthiness as opposed to truth. Truthfulness. Well, it's a word. In JavaScript, we could use any expression in conditionals, ands, ors, if statements, Boolean negations, and more. As an example, if statements don't expect their condition to always have the type Boolean. Ah, right. If numbers online, so I guess 0 would be false here, right? Yeah. In JavaScript, constructs like if first coerce their conditions to Booleans to make sense of them, and then choose their branches depending on whether the result is true or false. You see, this is the difference of like working with an older language, like, Rust or whatever. Newer languages won't really have this same kind of problem. It's just too error prone. Values like 0, not a number, empty string, 0, n, null, undefined, all coerce to false, and other values get coerced to true. You can always coerce values to booleans by running them through the boolean function, or by using the shorter double boolean negation. The latter has the advantage that TypeScript infers a narrow, literal Boolean type true, while inferring the first as Boolean. Double negation, I see. So this will do not and not. It brings it back to a Boolean, the original value. That's cool. I assume they're like consecutive things rather than a single function. It's fairly popular to leverage this behavior. Well, let's check that out, huh? We could check it out. We could just do like, I don't think we need this. Is cold is equal to true, right? Okay, so that says true there. And now I run this with not, and it still be true. And now I run it with not, and it should be false. Yep. So it looks like it's being used one at a time. So that means we could do not, and it's true again. Okay. It's fairly popular to leverage this behavior, especially for guarding against values like null or undefined. As an example, let's try using it for our print all function. What does this do? You can even give it a string or an array of strings or null. Hey Findus, how are you? I still have like a stuffy nose. It's really sucky. It's fairly popular. Okay, so we pass in strings, which can be a string, an array of strings or null. And if strings exist and I see type of is an object, then it means it's an array. So we could basically print each one out. Otherwise, we check if it's equal to string, the type of it, and then we log it. So like, I don't know. Like, this looks okay, right? 1, 2 here, it prints it out. But doesn't this code look ugly? It's almost like, yeah, it's good to see you also. It almost feels like what I'd want to do is return like a symbol here, not a string, you know? Like, I would have like array. Maybe something like this. Yeah, let's just do it lowercase. Array type equals symbol array. And then we'll have like object type, and those are all different kinds of the other kinds of object. And then we should have like a null type, no? That's separate. And then we could have like a string type. And then we make a function called like get type, and we pass it some object, something. Let's call it x. X is always good. And it could be an object, or it could be a string, or it could be null, right? An object would be an array also. And it returns what should we call this? Like type of. Or object t, or null t, or string t. Uh-oh. Alright. Yeah, you only have to do this once. And then you have get type, which is going to return a type t. And then you have like should we switch? So if it is a string, then we're easy, right? Then we return string t. It's not this, is it? It's this. Otherwise, all these other things are objects. Yeah, I guess I probably should have used type of. Let's just do if. If type of x then we return string t. I bet I don't even need this, right? Else what is it? Else if? Um so it's not a string. So we're doing else if it's an object. Now we have a couple of choices here. If let's just like not keep running type of, right? So if the type of x is string, do this. If its type of x is object, then we need to know if type of x is, how do you say null? How do you check if it's null? Oh, it's over here, right? I think we can say then return null. I'll return null t. Now we know that it is either an array or an object, right? So here we go, else if do if type x if array dot is array x. We probably should have done that earlier on, and then we could just return array type. Otherwise, we know it is an object. I think this is right. Well, let's test it. So we're gonna call get type. We'll pass it an object. Symbol object. So this says it's an object. Let's pass it null. Uh-oh. Oh. This did not work. I still have an error. Function lacks ending return statement, does not include undefined. I thought that was just not. Well, let's keep going. So we tried what? Object. Now let's try a string. So that returned a string worked. Let's try an array. That returned an array. Let's try an empty array. Make sure that also works. So it's just null. And I thought null is basically if this. It should say it's an object. So null is an object. Oh, whoops. So it is an object. If not type X. Maybe I should just do if it is, this means if it is. So this means if it isn't null, then we can be like, okay, it's an array. Otherwise object. Unreachable code. Why does it say this? I thought this is how you check if it's null. Get type null. Oh, what? Why is it not printing anything out? Oh, I have like a problem here. This closes this. This closes that. There we go. Is object. And let's try it here. That says is not null. Oh, so null falls in here. That's because I'm putting in the wrong thing. There we go. There we go. That's better. Function lacks return statement. Well, if you go through here, then we have a problem. Okay, so all the errors are gone. We got ugly code. Why are we writing this? Because now if you have code like this, you see, like, if we had a function like print strings, you could do this now. Here, let's write a new version of this now. Print all 2. I think I would just do a switch. I keep pushing this switch thing, right? Get type of, what's it called? String of esters. And if it is this one is supposed to be an array, right? And here is string type. And then default, you do nothing. Right? All right. So the question, folks, is, well, let's check if this works. print all 2, and we can give it a string, foobar, and it printed out foobar, you see? Let's do that again. Run foobar, you see that? And now, oh, why is it not happy here? Possibly null. No, it can't be null. That would be here. If it's an array, it can't be, well, we'll see it in a second, right? We'll see if it works. And now we give it an array. Oh, we should get rid of the console logging here. So it does both, right? Because it's an array. And now if I pass a null, it does nothing. Because we have like basically a case here that is null t. We got a null value. There we go. But it's not happy because it's not smart enough to realize that like strings might be null. It really can't be null because get type, we're checking if it's null here. So if we say it's an array, then we've come through here and we know that it's not null. You see? So anyway, the question is this code better where you do type of strings equals object? Like, the problem I have with this is you might type something wrong here, you know? Like, or, I don't know, that it has to do a comparison. Doesn't this look a little bit better? It's an array, it's a string. Like, you don't even know what you're looking at here. You're like, oh, it's an object, so actually this is an array. Here it says, oh, it's an array. Anyway, I guess everyone has their own, like, sort of. I imagine this isn't necessary, right? Alright, maybe we'll save this because maybe one day I'll use this again. But I should clean this up. I bet it could be made a lot better. Alright. You'll notice that we've gotten rid of the error above by checking if string stirs is truthy. This at least prevents us from dreaded errors where we run our code like null is not iterable. Keep in mind, though, that truthiness checking on primitives can often be error prone. As an example, consider a different attempt at writing print all. Don't do this. Keep reading. If type of strings is equal to object, do this. Else if strings is equal to string, do that. Alright, let's see what's wrong here. If it's strings, we know that it's not null. And here we know that it's an object. Okay, why is this bad? We wrap the entire body of this function truthy check, but it has a subtle downside. We may no longer be handling the empty string case correctly. Oh, because do I have this problem? No, I don't have this problem because I check if it's a string right up front. Here, watch. So if I make this a string, it's null. But if I make this an empty string, oh, I don't want to print it. I want to get type. It says it's a string. Yeah, so we handle that all right. We're in good shape. We've thought of this. Not really, but yeah, we're in good shape. TypeScript doesn't hurt us here at all, but this behavior is worth noting if you're less familiar with JavaScript. TypeScript can often help you catch bugs early on. So maybe I should make a note of this because that is tricky, like JavaScript. Empty string and what, like null are both objects. No, both evaluate to false when used in a truthy expression. If is true, is false. Okay. TypeScript can often help you catch bugs early on, but if you choose to do nothing with a value, there's only so much that it can do without being overly prescriptive. If you want, you can make sure you handle situations like this with a linter. One last word on narrowing by truthiness is that Boolean negations, bang, filter out from negated branches. What? Oh, here? So this is like basically in case it's undefined, we can use bang and now it's safe to use. No, that means it is undefined. I don't understand. Undefined, if it's undefined, then it's going to return, like, values is false, so it turns it to true. It'll just return undefined. Why would you want to return undefined, though? I guess that's your option. You can just say return undefined, right? I think it'd be clearer. Return values map. Right, okay. Equality narrowing. TypeScript also uses switch statements and equality checks like blah 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 to narrow types. For example, if x is equal to y, now we could call any string method. Oh, because it could only be a string if they're both equal, because otherwise it's a number or boolean and those things aren't strings. That's pretty cool. When we checked that x and y are both equal in the above example, TypeScript knew their types also had to be equal, since string is the only common type that both x and y could take on. Yeah, I'm a little sick still. Iron my DSR. Like, I feel much better, but you can still hear that, like, my nose is clogged. But the weird thing is, before I was streaming, my nose wasn't so clogged, so I think it's just sitting down and doing this makes me, like, worse. Maybe I'm just dying. Did I have lunch yet? I don't think I had lunch. At 3 p.m. I'm just not very good at staying alive. That's my problem. How are you doing? Let's see. Since string is the only common thing, then we know it must be a string, right? You guys saw this, right? X is a string, Y is a string, and if we say they're equal, then obviously they can't be a number and a boolean or a number and a string. The only way they could be equal if they're both strings. Checking against specific literal values as opposed to variables works also. In our section about truthiness narrowing, we wrote a printall function which was error prone because it accidentally didn't handle empty strings properly. Instead, we could have done a specific check to block out null, and TypeScript still correctly removes null from the type of strings. There's so many things. There's like nulls. There's like, did I write them down? Null types. Undefined, void, and null. Like, seriously? Why do I need so many? Thanks for being an inspiration. I'm autistic and have a hard time communicating with people. Don't mind my words. Don't worry. Yeah, thank you. I think I saw your comment. I just haven't replied to YouTube comments yet. Thank you for your comments and everything. Good job coding. Where are we? Print all error prone. TypeScript show correctly. Instead, we could have done a specific check to block out null s. I see. If it doesn't equal null, but we don't want to do this, right? We want to say if not strings, then like return. That way we don't have so many nested stuff. Like if we take this code here, oh, we have it here already, right? So they're saying it doesn't handle what? If it's not null, but they do it at the top here. So if we call print all when we run this, it's undefined because here, when we look at strings here, it might be null. If strings, I don't understand why this is saying undefined. Let's see where it's going. So we know it's an object. Otherwise we know it's a string. But like this is not where it is. It's definitely not in string. Strings is possibly null. That's our code though. Oh. I don't need to do print all. I just need to do print because we're already logging. That's what the problem is. Yeah, it doesn't print anything because it's null. So are they trying to change that? No, they're not. I actually don't understand the problem here. In our section about truth, we wrote a print all that was error prone because it actually didn't handle empty strings. Right. Didn't handle empty strings. So let's try to, let's see. So if we passed in the empty string here, it would think it's an object, right? Yeah, it's in strings. So doesn't it handle it fine? I think they're wrong here. It does handle it fine. It prints out the empty string. Because we're checking if it's a string. And it should be a string. I think these guys are literally crazy here. How'd I get you into coding? Would like to hear about your journey. Oh, let me finish reading. Sorry. Have a good day, and you don't have to respond to my comment being here. All I need, but you have a good day, and make sure to take care of yourself, and always smile, and make sure keep your head up. Yes, I'm trying to smile. How did I get into coding? I think like I just ever since I was a kid and I saw my first computer, I was like, oh, what is this? And someone had like some code, and I was just like, how do I do this? So I just tried to read coding books when I was like a little kid. I wanted to make like video games, and that's kind of how I started. I just like learned on my own. I don't think there's any problem with the example they provide here. They say they don't handle the null, the empty string very well, but I think they're wrong because you see when we're here, we're checking an actual, is it not null, right? Because we're saying stirs. And then we say, and it's a type of object. Because null is an object, right? So that's what we have to be careful of. So at this point, we know that it's not null, and we know it's an object, so therefore we know we could call this. So what could it be here? It could be either an object or it could be null still, right? But we're checking if it's a string. So there's no way for this to be null here. but they seem to think that it is because you look up here. Where was their print doll? Oh, maybe they're referring to this print doll. Here, let's copy this print doll. Maybe this is what they don't like. Let us replace it with this print doll. This is a bad print doll. Yeah, this is what they must be talking about. So here we have a function that it's checking if it's not null, right? And here we're checking if it's an object, so this must be an array, therefore we iterate through the array. Otherwise, we know that we check if it's a string, and we print out the string. So the problem is, do we filter out the empty string? If empty string returns false when it turns into truthiness value, so it's going to fall down and we won't actually print out the empty string. So let's try this out. So first we'll do foo, and it prints out foo, but then we give it an empty string and we run it and it doesn't print anything out. Yeah, that was the error they're talking about. Congrats to your job. I have been coding for not that long, but learning new things every day. Yeah, it never ends. Well, I guess I just learned back something today that type of null is object. Yeah, seriously, it's crazy, right? So now what we want to do here is they said, okay, why don't you just wrap the whole thing and say like if strings doesn't equal null. I think that's what they were saying, right? Yeah, if strings doesn't equal null, and now this should work. Yeah, we print out the empty string, right? Instead of just if strs. How do I feel about this? I don't love it. Like, here's an example. You could either have this function, right? Or you could have this function. I would just do if it's equal to null. Then return. The rest of this just like goes back to its regular logic. And now if you run this, it still prints the same thing, right? So like you look at this function, it's like nested 2 levels deep. It could get a little 1, 2, 3, and now you're fourth in, right? Here you're only going 1, 2, 3. So you're going 1 level less because you're like don't have to worry about null anymore because you've literally told it to return. Yeah, that's how people would do it, right? But like I was showing the other code that I wrote was this was my version where I just made types. So I explicitly don't have to even think. I just go, if it's an array, I called it out rather than having it's an object and it's also like I don't know, it's an object, so definitely it's an array. Like that's just stupid, right? So I just call get type. You don't have to call is array or anything. Get type, I made a function, and then we get array string null, and it works. So I could do print all 2, and this will print all 2. we got a null value. All right. Just seeing code like this, it's just, I feel like it's just bad. Like, just assumes that you have to know the intricacies of JavaScript. Whereas, like, if you just see, like, these are types, that just seems a lot easier, no? Yeah, I made this type T. Okay, let's see. Where are we? Screeps, everyone. JavaScript's looser equality checks with equal, equal, and not equal also get narrowed correctly. If you're unfamiliar, type checking something with double equal, equal, null actually does not check whether it's specifically the value null. It also checks whether it's potentially undefined. The same thing applies to equal, equal, undefined. It checks whether a value is null or undefined. So equal, 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 like really checks for it, and equal, equal kind of like is looser. Can a value be void also, or it's not really a value? Can something be void type? Yeah, right? I think you can be. Is void the same thing as undefined? How do you know if it's an actual array in your get type function? Good question. I just call isArray. IsArray. I could probably clean up this function. Like, wouldn't it be better to put this up here, maybe? Right? And at this point, I don't know if it is a null or an object. Does that seem right? So, is there an assert? No. Um, get type null is equal to null t, right? Here are the tests. And then we're like, what is all do? All. That doesn't work, huh? How do you say array? Like this? No. Let's just try to print tests. False, true. Get type. Why do we have an error here? God, I swear, like, JavaScript feels tough for me still. Symbol object, so it thinks it's an object. That's because I need to compare this with X. There we go. True, true. There we go. All good now. We were comparing the type of instead of just the object. If I want to compare with null, I should just take the object and compare with null, the X itself. So we're checking null, we're check strings. No, we should give it an array now. Oh, I didn't make an array. Oh, I did. And what was the last one? String, array, object. Oh, object. Is that an object? True, 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 true. Now isn't there a way to do like all? Is this it? Uh, at every, oh, it's called every. The predicate function. I assume I can just pass nothing. No? 1 to 2 arguments. You have to give it a predicate. Wow, that's a really stupid function. True. You guys might not see that. Run. True. Yay. So I'm just making a function that's like, if it's true, then return true. Or whatever Boolean, return it. So if I have something in here that's false, like one test that fails, that should fail. Now it says false. All of them have to be true for this to work. My little cheap unit test framework. Wow, I'm going so slow. Like I'm moved like that. I'm like a third of the way through with this page on narrowing. Crazy, right? But I'm like trying to write the code to test, so I don't blame myself. We actually looked at this. Interface container something. Remove both null and undefined from the type. If it's not null, do this. So this is narrowing right here. If it's not null, sure, it'd be a lot easier if they like didn't have null as a possible container type, right? Then you don't have to have this in your code. The in operator narrowing. Oh, this is cool. This sounds like it's good syntactic sugar. JavaScript has an operator for determining if an object or its prototype chain has a property with a name. I don't know what prototype chain is. I assume that is like object-oriented programming. Wouldn't filter Boolean work for that case too? Filter usually is looking for a value, right? You're passing in a predicate for filter. Let's look it up. Filter. So yeah, you're passing in something here, right? So you mean like basically it'll tell me which one doesn't work? Yeah, that actually makes sense. In which case, like, we would sort of change this test to pass in like two elements, left side, right side. And then when it fails, we could actually print out what were the two things that don't match. You're right. Like, that's probably better. But my cheap ass version is just like, did all tests pass or not? That's all I wanted to know. But filter would tell you how many tests failed, but we would have to change the actual like tests array here for it to be like better. We could be like left, right. You see what you're making me do? This is why we never make progress. Why doesn't it like this? Ah, right. What is it? How do you do? Like Boolean is how you would normally do it, right? Yeah. So now we need an object prototype. We call it like type. It's all your fault. Oh no, this is not, we don't know what it is. We just want to know if they're equal. So really they could be any, right? Now we have to run each one. I guess like this. True, but now what we can do is filter where they don't equal. And then when we have one that fails, oh, how do I print it then? Why is it not printing this out correctly? We would have to check if the filtered array length is equal to 0. Where, what, why? Whoops. I don't know why it's not printing stuff though. See this, it should log test filter. So what's left is the filter where it failed, which would be an object that has a left and a right. So why isn't it printing the left and the right? Here, let's just print them out. We'll just do console.log tests. Oh, what? It doesn't know how to print these things? That's probably why. Maybe I need like a toString? Well, anyway, I don't want to spend too much time on this. Somehow this isn't working, and one day when we get far enough in TypeScript, we'll know why. But I wanted to basically print out this object, but it seems to not be able to, probably because it doesn't know how to print an array of objects. But we know it works. It's just that it prints it out as empty here, right? That's just the only lame part. Alright, so where are we? For example, when the code value in X, where value is a string, literal, I don't understand any of these words. I don't understand. What is this all saying? Let's just look at this. Swim is a function that returns void. Fly is a function that returns void. So it's saying that a fish is an object that has a swim property that is a function and a fly property that's a function. So now we know we can take in, if we take in an animal that's either a fish or a bird. Um, oh, we're checking if swim is inside animal. If there's a property, then we can do animal.swim because that means that swim must be this function. Wow, that is the ugliest shit I've ever seen. Wow, is this how you have to write it? I hope not. Like, I think I would probably have another. I would have just like extended these things, like movable fish or something. Movable. And then move would take in a movable instead of an animal. To reiterate, optional properties, and I'm not going to write that now because then I'll never finish. To reiterate, optional properties will exist in both sides for narrowing. For example, a human could both swim and fly with the right equipment and thus should show up on both sides of the in check. Alright. So perhaps a human can swim, in which case, if you say it swims, then it will show up as possibly a human. So you have to handle that situation. Instance of narrowing. JavaScript has an operator for checking whether or not a value is an instance of another value. More specifically, in JavaScript, X instance of foo checks whether the prototype chain of X contains foo.prototype. While we won't dive deep here, and you'll see more of this when we get into classes, they can still be useful for most values that can be constructed with new. As you might have guessed, instance of is also a type guard, and TypeScript narrows and branches guarded by instance ofs. So let's add this here to say what's animal? What was it? In an instance of. Okay, so we can narrow it with these guards. Assignment. As we mentioned earlier, when we assign to any variable, TypeScript looks at the right side of the assignment and narrows the left side appropriately. Okay, yeah, so this might be yeah, I hope we don't write code like this, but yep. You guys see that, right? Like, Here, if it's a random number and it's like between, if it's less than 0.5, then we return 10. Otherwise, we return a string. This is a number and this is a string. So now we see here that the inference that it makes is it's either a string or a number. But if we just do x equals 1, then x is just a number or a string. It would be nice to finish this section today. So I'm just trying to hang in there till I can finish. Notice that each of these assignments is valid, even though the observed type of x changed to number after our first assignment, we're still able to assign. Yeah, I think all of this is very obvious, so I'm going to skip that. Control flow analysis. Up until this point, we've gone through some basic examples of how TypeScript narrows within specific branches, but there's a bit more going on than just walking up from every variable and looking for its type guards and if, whiles, conditionals, etc. For example, we got our pad left function. We do type of padding is number. Okay, so what's special here? Pad left returns from its first if block. TypeScript was able to analyze this code and see that the rest of the body return padding is unreachable in the case where padding is a number. As a result, it was able to remove number from the type padding, right? The analysis of code based on reachability is called control flow analysis in TypeScript. God, this is so basic for me because like if you use Elixir and you use Dialyzer, like yeah, you're so used to this, but it's really annoying. So what's going on here? We see that x is one of these three things. X is a number, so at this point we know that it's a number, right? Oh, it's less than, so this is Boolean. So this is definitely a Boolean. If x equals hello, so it's a string here. X equals 100, it's a number. Return x. You have to see what's left, and it's a string or a number. Lucky you to find it basic. For me, every topic of TypeScript makes my brain melt. Kappa. Kappa, kappa. Yeah, my brain melted with Elixir Dialyzer, so it's less melted for this part. Using type predicates. Okay, we're getting closer. Let me bring the browser in so you can see. See, we're here now. We're like right above my video. God, like I want to play video games. Why am I doing this? Using type predicates, we've worked with existing JavaScript constructs to handle narrowing so far. However, sometimes you want more direct control over blah blah blah. Uh, to to define a user-defined type guard, we simply need to define a function whose return type is a type predicator. Predicate. Oh, we say is. So we're passing is fish, we pass in a pet. It's either a fish or a bird, but we're going to tell it pet is fish. Then we're checking, we're going to basically cast it to a fish and see if the swim property is defined or not. Pet is fish is our type predicate in this example. A predicate takes in the form parameter name is type, where parameter name must be the name of a parameter from the current function signature. Anytime isFish is called with some variable, TypeScript will narrow that variable to that specific type if the original type is compatible. If isFish pet, pet.swim. You see, what I don't understand here is they told us that the as will not let you narrow it to an unrelated type. So let's watch this. I'm gonna keep this. I'm gonna keep this in our gist for later. Our updated version. I should just commit some of this to Git, right? Like actual commit. Now we can erase everything. It's getting cold. Oh! I zipped my hair. I wonder if I could just close my... Where are we? What were we doing? I dissociate a lot, so I forget what's going on. Right, we're gonna look at the as operator because something didn't make sense. Let's make a type bear. Uh, this isn't really a good example, is it? And then we wanted a function, didn't we? We'll just make a function. Claw somebody. We'll call it mall. So it takes an animal and it returns the damage. And maybe fish has a bubble attack. should make an animal, shouldn't we? This makes sense. How do I make a bear now? So we have animals that have health, we have a bear that can maul, and we have a fish that can do a bubble attack. And we made a bear, and I'm giving it a maul function that we ignore the animal, but we return 10, which is the damage it does. Let's run this. Console bear does. I'm guessing we have to we have to add a toString object. It's probably not doing that, right? Well, it doesn't matter. So I'm going to maul an animal. So it says it did 10 damage. Maybe we should return the health of the animal minus the damage we do. How is it that we're making a video game now? Why did this happen? So now we have 90 health left on the animal after we maul this poor animal. Let's make an animal. Let's make a rabbit. His health is only 15 because he's just a little rabbit. So he's gonna maul the rabbit. So now the rabbit has only 5 health left. Console.dir? What's that? Oh, you guys don't see very well, but yeah, it's only 5 health left. Oh, it lists the properties. No, it didn't do much. Uh, unless we need to console log that. I hope not. That would be really bad. Nope. Anyway, we're slowly killing the rabbit, right? Sage. We're very sad. Okay, we're killing the rabbit. I got so involved in killing the rabbit, I forgot why I'm doing this. All right, right, the as thing. Oh my god, my ADHD is so acting up. Oh my god, we're falling apart. Right. So now I want a function that basically means like this is a stupid example, but like function do bear attack. But we're gonna pass in a creature here. And it could be like an animal, it could be an animal, or it can be a fish, or it can be a bear, because we're trying to do what the other thing did, right? Like the example they gave us. So we start easy. We start with just a bear, and obviously we're going to say like do bear attack. So we have to pass in the bear. So we'll say the bear we pass in, and then the target, right? So now we can do target has to be an animal. So we do this, right? And it's happy because it knows that mall is a property of this, of bear. So now we can do bear attack. We pass in the bear and the rabbit, and everyone's happy. Oh, do bear attack. It has to return this. 5. So the rabbit now has 5 health left. But the question is, what if bear might be a bear or it might be a fish? Now we can't call mall anymore, right? The rabbit survived. Well, we'll have to return the updated rabbit and then it won't survive. So for now, we'll return a number. So when I get rid of this fish thing, it's happy, right? Yep. But what I'm trying to figure out is we don't know, when we look at bear here, it might be a bear or a fish, right? So if I go, what was the thing they said? Let B equals bear as bear. Holy shit, it lets me do this? Yeah, a small game, right? A small game, why not? I just do little examples and sometimes they turn into small games. Bear is bear. Wow, this is bad. if b dot mol return this. If we then we can, otherwise we just return, I don't know, 0. Okay, so now it works. It's happy because I turned into a bear, but I check if it can mol. But would this work if I got rid of this? This is going to give me a runtime exception, right? Oh, no, because I didn't pass a fish. Let's make a fish. And we have to give it bubble attack. It takes an animal. I can't type today. Animal. Okay, so we have a fish. Let's try passing a fish here now. It thinks it's fine, but when we run it, it says bmol is not a function. Right. But that works if we check. And now they're saying we can write a predicate is bear, which I assume takes in, let's say, something, which could be a bear or a fish or an animal. And it returns we have to say x is bear? Or is it just is bear? Something like this. And then we do if x dot mol, I keep typing mail, then we return true. So which means I can just say return x dot mol. This will return a function. So I can do this to turn it into a Boolean value. Let's see, is bear. Pet is fish. Oh, right. So we have to do, but isn't that what I did? X is bear. All right. So we have to do x as bear dot mol. So now I have an is bear predicate. So I can say if is bear bear, if is bear Why are you not happy? Oh, you need a parentheses. Oh, JavaScript. You're so... Alright, so let's see. Does this work? If it's bear, then we're going to do a bear mall, and we're doing a fish. We return 0. So if it return -1, then obviously... Here, I'll clear run. It returns -1, which is clearly like thinking it's not a bear, right? But if we do pass in a bear here, then we get 5 back because it does its mall. So we did it. We did it. We wrote a predicate. And we also wrote a stupid thing here. Number. What are you going on about here? Oh, let fish equals fish. But poor fish only does a little bit of damage. There we go. All right. Um, but if the fish attacked a rabbit, it's only going to do 1 point of damage, so it should only get 9 health. Oops. Oh, because I did do bear attack. I should say do attack. I'll just call it attack. If is bear, then do bear.mall. Else, we know it's a fish, right? So we can do, and we shouldn't call this bear attacker. There we go. Then we do attacker dot. You see it filled out bubble attack because it knows that it has to be a fish. All right, so now we're going to attack as a fish. Right? We're going to attack the rabbit as a fish. 14. Oh, the animal health had 15 to start with. We did 1 point of damage, and it only has 14 health left. So, do I save all of this as an example for type predicate? That just seems crazy. That is a terrible example because it's so long. Well, this is my thing, so who cares, right? What are we doing here? This is called guards. I guess it's like writing your own predicate, so it's a custom guard. All right. So now we have our custom example for a custom predicate is bear. Uh Assertion functions. Alright, I think I have to go to the bathroom before we keep going. So I'll be right back. I think I have a message to do that. Where is it? I say making coffee, but like, I'm not making coffee. I'm going to the bathroom. Maybe I should make coffee. Maybe I will make coffee. I'll make this statement true. I'll make coffee. Okay, we're back. Let's see. We're doing type predicates. We did this part already. um, yeah, so we said the if fish thing, we made it is bear. Notice that TypeScript not only knows that pet is a fish in the if branch, but also knows that in the else branch, you don't have a fish. Yeah. Assertion functions. Types can also be narrowed using assertion functions. Discriminated unions. Most of the examples we've looked at so far have focused around narrowing single variables with simple types like string, boolean, and number. While this is common, most of the time in JavaScript, we'll be dealing with slightly more complex structures. For some motivation, let's imagine we're trying to encode shapes like circles and squares. Circles keep track of their radiuses, and squares keep track of their side lengths. Let's use a field called kind to tell which shape we're dealing with. Here's a first attempt at defining shape. I would never write it this way, but whatever. Notice we're using a union of string literal types circle and square to tell us whether we should treat the shape as a circle or square respectively. By using circle or square instead of string, we can avoid misspelling issues. Right, by saying this, you're avoiding misspelling instead of just saying kind is a string. Right. Function handle shape. Shape is the parameter. Oops, shape.kind equals rect. This comparison appears to be unintentional because the types circle, square, and rect have no overlap. Alright, it's just saying it can't be a rectangle because this is what you passed in and this is what it's expecting. We can write a get area function that applies the right logic based on if it's dealing with a circle or square. We'll first try dealing with circles. Shape.radius. Shape, right. Maybe we should do this. Let's see our version. We'll stick to their thing. The question mark means it's optional. I think this is what it was. And then they said something like they wanted to make, what was it? Get radius, get area. All right, so what is the area? We want to know if it is a square or a circle. I guess I could just do an if. I guess we can do a switch because maybe there'll be more in the future. We want to do circle first. Yeah, radius is not, we don't know that there's a radius. So let's return a number because area is a number. And then we're returning math pi. We're getting the radius. We're assuming the property exists if it's a circle. So I put a bang there. And then times 2. So let's make a circle. Okay, why isn't it like this? Identifier expected. All right. Equals. So we have my circle. Now we can get area my circle. And I'll just do console.log. Yeah. Okay, there we go. Is that right? Think so. Um, I don't know what I'm not thinking about, but like obviously if the circle has no radius defined, then this will fail. Like here. But we kind of assume that it will be. Let's see what they do. Under strict null check gives us an error. Radius might not be defined, but what if we perform the appropriate checks on the kind property? Still, it's possibly undefined, of course. Because when we define the shape here, we don't know that there's nothing that says the circle should have it. And that's what I did here. And it definitely doesn't feel ideal because someone could code this wrong. Instead, we should make a circle type that definitely has a radius. We had to shout a bit at the type checker with those non-null assertions to convince it that shape.radius was defined, but those assertions are error prone if we start to move code around. Additionally, outside of strict null checks, we're able to accidentally access any of those fields anyway, since operational properties are just assumed to be present when reading them. We can definitely do better. The problem with this encoding of shape is that the type checker doesn't have any way to know whether or not radius or side length are present based on the kind property. We need to communicate what we know to the type checker. With that in mind, let's take another swing at defining shape. Yeah, this is so much better. You could make it better by having like a base interface that just has kind and these extend it, but whatever. Here we've properly separated shape out into two types with different values for the kind property, but radius and side length are declared as required properties in their respective types. Let's see what happens here when we try to access the radius of a shape. So here we're just passing a shape and not a circle. So obviously it could end up being um, a square. So it's not safe. So look, what are they going to do? They're going to just check if it's equal to circle, and now everything's fine because when you check that kind is equal to circle, now it knows it narrowed it down to this circle type. That's here. We got rid of the error. When every type in a union contains a common property with literal types, TypeScript considers that to be a discriminated union and can narrow out the members of the union. So you need to make sure that that property is available in every type that is in the union for it to narrow it down successfully. Sorry. Let's put that in here. I don't know that I will actually remember what I'm talking about, but we can always look it up later. Alright, so that's another type of guard in a way. Discriminated union, not discriminating union. Do you stream tomorrow? I should be. Tomorrow's not a busy day. Let's see. Yeah, tomorrow I expect to be streaming. How you doing, Findus? Alright, so we got discriminated things out of the way. Now we got get area with the shape and we check that. It's a circle, we do this, everything's fine. Otherwise it's a square. I see, so it works. They did a switch statement, it works, everyone's happy. As an aside, try playing around with the above example and remove some of the return keywords. Yeah, I think we get it. The never type. Ooh, we're almost at the end now. We're so close to the end. Oh, I forgot about my coffee. At least the coffee is warm, so when I touch it, my hands warm up. This next section should be cool. More on functions, then object types, type manipulation. I wonder why this has a thing here. I hope each one here, is it going to be huge? No, they're short. Creating generics is long. No, a lot of these are short. You ever do this when you know you have to read stuff in the future? Like you're like just kind of looking ahead to see how big, how much you have left. When it's a book, you can kind of just like, when it's a book, you could kind of just like feel it out, right? You're like, oh, I look at the side and I'm halfway through or whatever. But when it's a website, you just have no idea because you don't know how many pages there are. When narrowing, you can reduce the options to a point where you removed all possibilities. It will give you a never type. The never type is assignable to every type. However, no type is assignable to never, except never itself. So every type can become never, but you can't ever make a never type. This means you can use narrowing and rely on never turning up to do exhaustive checking in a switch statement. For example, adding a default to our get area function which tries to assign the shape to never will not raise an error when every possible case has been handled. Aha! At this point, if you've done these two things, then this shape is a never because it can't be anything else. So you can just like basically say, oh, it's a never, and you won't get any TypeScript errors. But if you add a new type, triangle, then this will give you something because it says, oh, it's actually not a never. That's really cool. I'm going to write that down because I want to do this. I'll say used in switch default statements. It's probably the most common use case. And we're done! Yay! Alright, we'll stop here. And next time we will do more on functions. Generic functions, parameters, a lot to learn still, more never stuff. Rest, I see the rest of the stuff. Well, there we go. That's it. I hope you learned something also. Someone said they learned about null being an object, so that's something good. JavaScript is weird that way, right? Thanks for hanging out. I don't think I'm going to do 6502 assembly today. I'm just too tired now. So thanks for hanging out. I want to finish TypeScript because I'll be starting this contract probably in a week. So it'd be good to finish these other chapters before the week's up. There's 1, 2, 3, 4, 5. So about a week is good. If we do one a day, but maybe I don't get to do it every day, so there's that. And then I really want to make progress on the 6502 assembly language. I really want to get progress with Nix. I want to install my own local mail server. I don't know if I'll stream doing that, but maybe. Why not, you know? Um, what else did I want to do? I'm not sure. We got to go back to COBOL too. There's so much to do, guys. So much to learn. I'm so excited. Like all this stuff, like I want to finish learning, you know? It just feels like every time I start something new, oh yeah, I have to learn Phoenix and Livewire, Livewire. That's a D&D spell or a Pathfinder 2e spell. Um, yeah, but we gotta finish stuff. We can't just keep starting learning new stuff. But at this point, you know, like we can definitely use TypeScript and probably know some stuff that others don't, because people don't usually learn like details like this. All right. Thanks everyone. That was very nice. We got a lot done. I really appreciate you hanging out with me. I'll see you all later. See you later. Bye.